Solving the soundproofing box issues, improving the lack of power, and revealing the C-axis performance beyond imagination. This is bad. It's definitely going to break someday. If we wait until it breaks, fixing it will be a real pain. I need to do something about it now. There are just too many problems.
Hey, freak. What's wrong? Did something go wrong again? I just love seeing you struggle.
Hey, Angel. I've been thinking. I'm a little worried that the slider on the soundproof box might break someday. I found this slider at a local DIY store, and I thought it would be cool if I could use it to pull the machine out of the box. And yeah, it worked, but the machine has gotten pretty heavy, and it's only going to get heavier, so I'm kind of worried.
Yeah, it does look cool, but this slider looks like it might snap. How heavy is it?
I don't really remember, but last time I checked, it was over 20 kilos. The biggest column isn't even done yet, and I haven't built the C-axis either. It's only going to get heavier. Plus, my workspace is ridiculously small for building this insanely cool 5-axis CNC machine. To make the most of the space, we'll probably end up working on top of this slider a lot. When that happens, there will be times when it takes more force than usual, which means it's even more likely to break.
So basically, this problem happened because you went ahead without a plan. Well, that's just who you are. Watching you mess things up is what makes it fun.
No, you've got it all wrong. The viewers are amazed by my flawless work and brilliant ideas. I have the determination to solve any problem and the genius mind to back it up. The word that suits me the least is failure. Probably.
Oh, I see. So, does the genius freak have some ridiculously genius solution?
Let's ask Ultimate GPT, the latest AI chatbot I built, for the solution.
Already relying on AI. Didn't we declare that AI a failure in the last video?
No need to worry. After the last video, I made perfect adjustments, so now it can provide concise and flawless answers. Now, let me show you the specially optimized Ultimate GPT. You'll be absolutely blown away by how amazing this AI is.
Hey, freak, Angel. Great to see you again.
Ultimate, give me a specific solution to prevent the soundproof box slider from breaking under the machine's weight.
If the slider isn't strong enough to support the weight, you should reinforce it from below.
What? That's it. I was expecting something groundbreaking, but even I could have said that.
Wow, Ultimate, your answer is absolutely perfect. I never would have thought that supporting a heavy object from below was the solution. Problem solved.
Huh. You call that a perfect answer? Even a grade schooler could say that.
The plan is set. All right, let's get started.
What are you starting? I have no idea.
Don't worry. My genius ideas are just beyond the understanding of ordinary people like you. It's not your fault. I'm just a genius.
Oh, really? Wait, you're making it open downward.
Yeah, that's right.
I have no idea what you're trying to do.
You'll see soon enough. Just stay quiet and watch my brilliant work.
I'm starting to see what you're trying to do. Why the creepy looking legs?
I've been jogging lately, and I think my legs have gotten more toned. What do you think?
Disgusting.
It's finished. No one but me could have come up with such a groundbreaking system. These rollers support the slider. Let's run a test. Perfect. Now, even if the machine gets heavier, the slider won't break.
Not bad, but it's just okay.
Next, I've decided to replace the X-axis and Z-axis motors with more powerful ones.
Why did you decide to change the motors? You just finished wiring them last time and finally got them running. Did you already break them?
No, I haven't broken it yet. As for why I'm replacing the motors, I found that the Z-axis motor is underpowered and moves erratically. This is probably because the motor is experiencing a heavy load, causing it to lose steps. The encoder detects the lost steps and tries to compensate, but it doesn't seem to be correcting it properly. Luckily, there's enough space where the motor is mounted, so I decided to swap it out for a slightly larger one. As for the X-axis, there's a different reason. Actually, when I built a CNC lathe before, I debated whether to use a servo motor or a closed-loop stepper motor for the spindle drive. In the end, I bought both, but I decided to go with the servo motor.
You just had a bigger stepper motor lying around.
Simply put, yeah, that's pretty much it. Besides, there's plenty of space to mount this bigger motor. Using a motor with enough power helps prevent issues. Alright, let's install it. Ultimate, explain the stepper motor replacement.
Today, we're upgrading from the ESS42P1X48 into the ESS42P2X60M stepper motor. The main differences between these two models are size and torque. The new ESS42P2X60M is 12mm longer at 60mm, allowing for a stronger internal coil and magnet. As a result, it delivers higher torque, making it more capable of handling heavier loads. This upgrade is particularly beneficial for the Z-axis, where load fluctuations are common, helping to prevent step loss and ensuring smoother, more stable operation.
Thanks, Ultimate. Since it was just a motor swap, there was nothing particularly difficult about it. Alright, let's run a test. The Z-axis seems to be working fine. I think it has enough power. Next, I'll replace the X-axis stepper motor. This one is significantly larger than the original motor.
Today, we are upgrading from the Hybrid Servo Nema23 closed-loop stepper motor, 1.2 Nm, to the Nema23 integrated stepper servo motor, 3 Newton meters. The key benefit of this upgrade is a significant increase in torque. The new ICE 573630 motor delivers 3 Newton meters of torque, up from 1.2 Newton meters, providing about 2.5 times more power. With a rated current of 5.0A, it can handle higher loads more effectively. This upgrade is especially beneficial for the X-axis, where fast movements and load changes occur frequently, ensuring more stable and reliable performance.
Thanks for the explanation, Ultimate. Alright, let's run a test. It feels really powerful.
The stepper motor sounds pretty loud. Why is it so noisy?
There are several reasons why bigger stepper motors tend to be noisy. First, stepper motors inherently produce vibrations and noise due to their design. Larger motors have increased rotor and stator mass, which amplifies resonance during operation, leading to louder vibrations. Additionally, high torque motors require stronger current pulses, which can cause coil and housing vibrations. This is especially noticeable at low speeds, where the motor may produce a grinding or chattering sound. The driver settings also play a role. If the microstepping setting is too low, each step becomes more abrupt, increasing vibration and noise. By adjusting the current settings and gear reduction, the noise can be reduced.
Next, we move on to the most important step in this video, adjusting the C-axis. But before that, there are still some unfinished parts, so I'm working on them now. Where it goes will become clear as you watch. As I'm making the parts, I'll also explain this machine's uniquely designed C-axis.
Didn't you post a video before explaining the structure of the C-axis? Why not use that to explain it?
Yeah, that's right. Looks like you're finally starting to get smarter under my influence. Ultimate, which video did we explain the C-axis in? I've made so many genius videos that it's hard to find.
It's not that many, is it, freak? You're just struggling with small text because of your presbyopia lately. Here's the video explaining the C-axis. This is the one where Freak was messing around in the explanation and got scolded by viewers.
Shut up. Just stop talking and find a part in this video where we explain the C-axis.
Got it? I'll start now.
This design eliminates backlash by applying light pressure in opposite directions to each other. Of course, each part must be assembled with high accuracy, otherwise it will not work properly. The most important part is the worm wheel unit, to which the worm wheel and taper bearing are attached. The worm wheel unit requires some important adjustments. The axis of rotation of the A-axis must be accurately perpendicular to the worm wheel. The center of the worm wheel must be accurately concentric with the axis of rotation of the A-axis. The tapered bearing must be press-fitted into the housing to eliminate rattling. Adjust the width of the frames on both sides to give preload to the bearings. You must not be able to resist wanting to know how I make these adjustments and assemblies with my limited tools and work environment.
All done. Did everyone understand the explanation? I'm a little worried.
Perfect. You won't find anyone else in the world who can explain things this flawlessly, except me. I envy my own abilities. If I were to be reborn, I'd want to be myself again.
Oh, Freak. That's amazing. I've never seen anyone who can praise themselves as much as you do. At this point, it might as well be a cursed talent. But honestly, you shouldn't say things like that out loud. People might realize you're an idiot.
Angel, Freak's brain is half rotten from all the alcohol. You're better off ignoring him.
Everyone seems to envy my talent. Let's get back to work before they start messing with me. The parts I was making earlier are spacers that connect the aluminum frame of the column to the C-axis frame. I've ensured that the tolerance of each spacer is within 0.05 millimeter. Now, I'll start adjusting the C-axis. I know it's functioning, but the real challenge is how much I can reduce the backlash. This is what it looks like when there's no preload on the worm gear at all. I'll adjust the position of one of the two worm gears to apply a slight preload. If the preload is too high, the resistance increases, and the motor won't be able to turn. On the other hand, if it's too low, backlash will occur, making precise machining impossible. I'll check to make sure there's no backlash at any angle. If the preload on the worm gear is too high, the motor won't turn and an error will occur. Actually, there's something that's been on my mind for a while.
What's on your mind?
It's about what lubricant to use for the worm gear. Right now, I'm using grease, but over time, it gets pushed to the outer edges of the gear. When that happens, it loses its effectiveness as a lubricant, increasing both resistance and wear on the gear.
Then why not use oil, like in a car engine? We could submerge the worm gear in oil.
I'd like to do that too, but using oil would require an oil pan, and if it's not sealed properly, it could leak everywhere. Structurally and space-wise, it's pretty difficult. Take a look at this 3D model of the A-axis. Designing an oil pan that encloses the worm wheel and worm shaft would be extremely difficult.
Why does it have to enclose everything? Since oil naturally drips down, wouldn't it be enough to have an oil pan just under the worm shaft?
Well, you might be right. There's a very small gap under the worm shaft, so I think we could fit a tiny oil pan there. Alright, let's add an oil pan to the 3D model. Here's what it looks like. The gap between the bottom of the oil pan and the worm shaft is very small. In fact, when we actually manufacture and install it, there's a chance they might even make contact. Since the worm shaft rotates, as long as there is a bit of oil pooled underneath it, the rotation will continuously supply oil to the worm wheel. We only need about 1 millimeter of oil in the small oil pan, so even if it overflows, it would be a very small amount. That should be an acceptable level.
This idea is thanks to me.
Thanks, Angel. It's all thanks to you. Let's go ahead and make the oil pan right away. They'll make an oil pan the same size as this block. The shape of the oil pan is done. But as it is, oil will leak from the seams at the 4 corners. To prevent that, I decided to add a layer of carbon fiber on the inside.
Why carbon fiber? You just need to seal the seams, right?
Good question. There's a logical reason for it. I want to get started right away, and the materials I have on hand are epoxy and carbon fiber. Plus, it looks cool.
So basically, there's no deep reason behind it. By the way, freak, this oil pan idea was mine, wasn't it? Normally, when someone gives you such a great idea, you'd want to thank them, right? I'm angel. So I can read your mind like it's my own. When you get an amazing idea from an angel as beautiful as me, you must feel like you need to give a proper thank you, don't you?
What? What are you trying to say? I already said thank you, didn't I?
It's okay, you don't have to say it all. I already know what you mean. You want to ask me what I want as a thank you gift, don't you? But you're too shy to say it, right? What I want is the newly released angel wings adorned with diamonds.
Oh, sorry to interrupt, but this is an important step. This is a method I came up with to easily create a smooth finish on carbon fiber. If you don't do anything, the surface will harden with bumps, and leveling it afterward is extremely difficult. So, I apply a layer of clear tape on the surface. Once it hardens, peeling off the tape leaves a perfectly smooth finish.
That's an interesting technique. I've never seen anyone do this before.
Angel, haven't you forgotten that I'm freak? With the tape applied, I can press it with my fingers to adjust the shape of the carbon fiber. Plus, since the tape is transparent, I can check if there are any gaps inside.
How did you come up with this method?
I failed a lot, tried different things, and discovered it by chance. After a day, it is fully cured. Now, I'm going to peel off the tape. It'll remove the excess carbon fiber.
It looks pretty good. For such a rough job, this turned out surprisingly well.
To check for leaks, I'll pour in some water. This size is perfect. I'll use this lubricant. The amount needed is very small. With this little, even if it overflows, it shouldn't be a big problem.
Is this little really enough?
We'll see when we try it. If it's not enough, we'll add more. I can see the oil being lifted in the direction of rotation. It looks like lubrication is circulating with just a tiny amount of oil. It's working even better than I expected.
This is working amazingly well. I must be a genius for coming up with such an idea. Hey, freak, about that thank you gift. What I want is the diamond angel wings.
Look at this. You can see the worm shaft lifting the oil and circulating it all the way to the worm wheel. Amazing.
That's impressive. By the way, about my gift.
All right. Next, I made another adjustment in the state to eliminate the backlash. Pay close attention.
By the way, about my gift.
Focus. I'm doing an important inspection right now. That's it for this video. Did you find it interesting? Next time, you'll be using this shaft to adjust the A-axis and X-axis. I think this process will be quite interesting. If you are interested in this project, I suggest you subscribe to my channel so you don't miss any videos. If you empathize with my project, why don't you become a member and support this channel? There are a few benefits, but as long as you are a member, your name will appear at the end of the videos as a patron. In other words, you can be a part of this project. So, please look forward to the next video.